So calculating DSCP values. Welcome to this session. In this session overall, my goal for you when you walk away is to be able to look at a DSCP value and understand what it means, especially the AF values that you may have heard about, like what do those mean? How does that relate to IP precedence and class selector and the CoS bits in the 802.1q header? It's like, how does all of this stuff relate? What do all these numbers mean? That's sort of my goal. Now, this is one of 4 tech talks that I am giving today and tomorrow. This morning, I did Introduction to QoS for Collaboration. We talked about low latency queuing and what are all the components of that, and what is the difference between policing and shaping, and what is queuing anyway, and that sort of stuff. That seemed to be a pretty successful session. We're doing calculating DSCP values today. And then tomorrow morning, I'm going to be setting up a globalized call routing call manager. And we're going to take a look at the dialed number analyzer and the route plan report to help you figure out troubleshooting, especially digit manipulation. That to me, there's with globalized call routing, the dial plan is so complex. Just being able to have tools to help you sort of get your brain around what you're looking at is a good thing. And then tomorrow afternoon session, I'm very excited about that too. I'm going to be having a Jabber client off-prem that is going to register via MRA back to Call Manager. And there are going to be a series of problems with this registration. And we are going to look at, where do I look to troubleshoot? When I see this, what does it mean? If I don't see something here, what does it mean? So that's where we're going. Okay, so for this session specifically, we're going to look at the ToS byte in the IP header. When I say it's a ToS byte, guess what? It's 8 bits, and that's pretty much all you need to know. We are then going to talk about what is IP precedence, how does it relate to class selector, and how do we deal with DSCP. What do the bits mean in the ToS byte? The binary to decimal conversion. And this trips a lot of people up because sometimes you include a bit and sometimes you don't. That makes things interesting. And the why we're going to be doing this. And that has to do with if you are typing something into a router into a class map, for instance, you need to put in a DSCP number, which may or may not be, I should say is related to, but is not the same as an assured forwarding value, for instance. And so how do you, convert between the two? Plus, to be perfectly honest, if you're planning to take a Cisco exam in the collaboration arena, I may or may not have seen a question related to that in a practice exam, shall we say. So it's good to know how to do these things. Talking about the behavior aggregates and the PHBs, and part of my purpose for all of that is you're going to see these terms. You're going to see PHB and it won't be defined. You're going to see AF and it won't be defined. You're going to see BA and it won't be defined. I would like you to be able to walk away knowing what these values mean. We're going to end with looking at the CoS bits in the 802.1q header and how, again, that relates to everything. So here we go. This is going to be just me talking and drawing. So let's get started. So in the IP header, there is a byte, the ToS byte. And a byte obviously has 8 bits in it. For the purposes of DSCP, we really only pay attention to 6 of those 8 bits. So let me draw out first a byte. We've got the 1s column, the 2s column, the 4s column, 8, 16, 32, and 64. 1, 2, 3, 4, 5, 6, 7. What am I missing? 1, 2, 4, 8, 16, 32, 64. Oh, right. And then 128. So that's a byte. And for the 8 bits in the ToS byte, that's awesome, except for the fact that we don't pay attention to these last 2 bits. They are reserved for future use, and so you just ignore them. And I mean totally 100% ignore those bits. So if we now take the remaining 6 bits and we put our new place values here, I've got the 1s, the 2s, 4, 16, 32, and oh, I missed one, sorry. Helps if I count correctly in binary. Thank you. Right. So DSCP values. This means that the values of DSCP can go anywhere from 0 to 63. There's 64 different kinds of values you can potentially do with DSCP. I don't know of any organization that marks their traffic so granularly that they need all of those values. So what are the purpose of these 3 bits, or these 6 bits? The first thing you want to do is sort of put a little line between the first 3 bits and the second 3 bits, and then sort of a line between these 2 bits and this last bit. When you see IP precedence, and if I'm spelling that incorrectly, my apologies. When you see class selector, we are talking really about these 3 bits. Anytime you have IP precedence or class selector, the remainder of these bits will always be zeros. So from a value standpoint, we're talking about 3 bits, right? So I've got values anywhere going from 0 through 7, right? Because that's what I can do with 8 bits, or 3 bits. I can make 8 different values. So my IP precedence can be 0, can be 1, 2, et cetera, all the way through 5, 6. Oops. 4, 5, thank you, 6, and 7. So those are our values, and I've got obviously some dots in there. There we go. Now, the deal with this is that back in the beginning, and we're talking about the olden days of networking, those 3 bits were all that were used, the first 3 bits. For anybody that has been around the military, you may be aware of the term flash or flash override traffic. That had to do with, remember, IP was originally built by the DoD, right, through DARPA. And so they wanted to be able to mark traffic at layer 3 so that it would go through networks, especially, think about time of war, and we want to make sure traffic goes through. And so they have flash traffic and flash override. When I was in the military back, more years ago than I care to count, I was in during Desert Storm, like the original, right? And I remember working, I was in military intelligence, and I remember working, and that was like the one time I ever saw flash traffic was when the bombings started, and the folks that we were listening to were reporting on this amongst each other in their communications, and we had to send flash traffic back to the NSA and all that. That's as high as you ever want to get. Flash override is never used. You just don't use it. And the story goes, I'm sorry, I'm telling you all sorts of historical stories, but I think this is really interesting stuff. So flash override, right? So the story goes, flash override in old, and I'm talking about the original, networks that the DoD was using. Hardware programming said that flash override traffic cannot be blocked. And where does flash override traffic go, at least back in those days? The Secretary of Defense. So there was this captain in Europe who was testing his new network, and he just said, well, let's do some flash override traffic, and I'll write an access control list here at the edge of our network to block the traffic. So a little bit later, he gets a call from the Secretary of Defense, wondering what's going on. So we don't use that. So if you're ever wondering why we never go up to 7, that's why we never go up to 7. And we generally don't use 6 either, the flash level. We generally are talking about 5 here. This is an IP of 5, this third to last guy here, right? So IP precedence 5, class selector 5, very high precedence. This is a high number in DSCP values, high number in IP precedence. Things like our RTP traffic. If you're going to do just straight IP precedence, 5. Now, we don't use IP precedence per se anymore. These days, we use class selector. Class selector was built to be backwards compatible with IP precedence. IP precedence is a much, much older sort of way of handling traffic, and we just, don't do that kind of thing anymore. I mention this because you're going to see CS, and we do use that in our modern QoS queues. You probably won't see IP precedence, but that's what those first 3 bits mean. It is the precedence of the traffic, the overall category of the traffic, and you can have 8 categories, only 6 of which is used. This category 0 is normal traffic. Category 5, so there's your 6 different values of RTP traffic, and you can mark these different traffics in different ways. Okay, so now let me go ahead and get rid of this part, and we'll start talking about the full DSCP values and how these are calculated, because that's really the overall thrust of this. There we go. So we've talked about IP precedence, we've talked about class selector. If I'm going to be marking these 6 bits for DSCP values, what do the 3 different sections here mean? The first thing to know is that this last bit is always a 0. So when you're calculating DSCP values, even though you're using 6 bits, only 5 of them count, and this last bit is always going to be marked as a 0. With the first 3 bits, again, we do class selector. With these 2 bits, we do what's known as drop probability. So you may have seen something like AF41. AF41, AF stands for assured forwarding. And 41 is going to be, I'm not on screen, am I? There we go, that should be better. AF41 is our video traffic. Assured forwarding is just a name we give this, 41. The 4 means that these first 3 bits are going to be 4. If you think of just these 3 bits, that's the 1, the 2's, and the 4's value. So assured forwarding, 41. The first 3 bits are a 1, 0, 0. And then the second number here, the second number is the drop probability. The lower the number, the lower the chance traffic will be dropped. So assured forwarding 41 will be 1, 0, 0, there's your 4. And then 0, 1, there's your 1. If I had AF33, well, AF33, the first 3 bits are this 3, so that would be a 0 and a 1 and a 1. And then the second bits would be a 3, and that would be, of course, 1 and 2, so you get 1 and 1. And that, as always, that last bit is 0. So when you're looking at DSCP values, the assured forwarding, when you're looking at, because this is where oftentimes, how it's mentioned or how it's talked about in class maps and whatnot, you'll see AF41 or AF32, that kind of thing. This is what we're talking about. This is how you map it out to the bits. There's one more value. So this is AF41. This is AF33. There's one more value I want to mention, and that is expedited forwarding. EF traffic. This is how we mark voice traffic in the actual RTP voice traffic in a network. Expedited forwarding is the highest precedence, and it sort of violates the rule of the first 3 bits are the precedence and the next 2 bits are the drop probability. With expedited forwarding, it is IP precedence or class selector 5. That's true. It's the only stuff that we really mark 5. And then while normally a high number here would be a high drop probability, for some reason, and you'd have to ask the engineers, I have no idea why they did that, but they did, EF is a 1, 1 here. Even though that means that would normally be like 53, and that means high drop probability, it just isn't. For expedited forwarding, it's a special case. That's one of those things you just sort of have to remember. Now, why is drop probability important? If you were here at the morning session, we talked about the hardware queue, and we talked about how the router is going to have several different software queues and needs to choose between the queues, which traffic's going to go into the hardware queue next so it can go out on the wire. And class-based weighted fair queuing, low latency queuing, is which queue gets a turn next. But one of the things I mentioned this morning is what happens if a queue gets full? What happens if the queue for the RTP traffic, let's just say it gets full. Well, if a queue gets full, then the next piece of traffic offered to the queue, I'm not talking about the egress hardware interface, but the next piece of traffic offered to the queue itself is going to get dropped. If I have AF41, AF42, and AF43 traffic, and that's all in the same queue, this is how I can allow the router to know, in the event you have to pull traffic out of a queue to make room for new incoming traffic that's important, which traffic gets to get dropped. And there's your drop probability. The truth is the router is going to reach in periodically to these queues and kind of throw away traffic here and there anyway, to make sure that the software queues never get full in the first place. But which traffic is it going to drop? It's going to drop the stuff with the high drop probability. And this is how it distinguishes. The treatment of these different values is supposed to be really based on the IP precedence piece, the class selector piece, but then there's also the drop probability. The reality is, I do have 6 bits that I can work with. I can really make 64 different classes of traffic with 64 different markings. You don't want to do that. That's way too many queues. You want, 3, 10, 13 maybe. So you have plenty of room to do the drop probability piece. So let me pause for a second and ask, the labeling of the bits and the fact that we ignore the last 2 and the last of the 6 is a 0 and assured forwarding and all that. Everybody okay so far? Perry, Sayed, Greg?
Yes, ma'am.
Okay, all right.
Good to go. Thank you.
Any questions about any of this so far? Because there's one more step on this and it's icky. So
let's get dirty.
All right, so now here's the problem with this. If I am going to be typing in a QoS class map, and I say that I would like to match anything that has a certain DSCP value, I would not say match IP DSCP, AF31. I wouldn't do that. What I would do is say match IP DSCP, and then I need the decimal value. And you're thinking to yourself, well, wait, I'm supposed to ignore these bits and not ignore these bits. It's like, how do I calculate decimal from here? So one of the reasons is commands like this. Another important reason is that when we are going to be working with layer 2, there are 3 bits in the 802.1 queue header, the COS class of service bits. And that originally was supposed to map exactly to IP precedence. That was, again, back in the day, those 3 bits matched these, gesturing at my screen, those 3 bits in the ToS, the class of service field would match my IP precedence exactly. But, we don't do that anymore. So in order to mark for multi-level switches, multi-layer switches, in order to mark traffic that's expedited forwarding correctly, or traffic that's AF41 correctly, when I go into the command line on the switch, I have to add the decimal values. So how do I go about creating decimal values for something like, well, actually, let's do AF33. Since I already have this here, right? How do I say, instead of match IP DSCP AF33, how do I figure out what the decimal number is? This is where this bit that I said was always a 0, this is where this comes back into play. So we have 8 bits, 1 through 128. We use 6 of them, 1 through 32, and then we have 2 groups, 3 groups. We have the group of 3, the group of 2, and the group of 1. When it comes time to go back and calculate the decimal number, you're going to use all 6 of these. So in the case of AF33 here, now I'm talking about using these 6 bits. I have a 1 in the 16s place. I have a 1 in the 8s place, that's 24. I have a 1 in the 4s place, that's 28. I have a 1 in the 2s place, that's 30. And then this bit here is always a 0. So I would say match IP DSCP 30. And that would be my AF33. To match IP DSCP AF41, because that's a common one to use. Okay, well, let's go back and count. I've got a 1 in the 32s place, and I got a 1 in the 2s place. So that's going to be AF34 or IP34. Match IP DSCP, SCP. I happen to know 46 is expedited forwarding because that's a number I've worked with a bunch, but where do I get that? A 1 in the 32s place, a 1 in the 8s place, that is 40, a 1 in the 4s place, and a 1 in the 2s place. There's your match IP DSCP 46. So if you're working with a command line in a router or a switch, the ability for you to take these bits and turn them into decimal numbers is, you need to know how to do that. There are charts out there, but it doesn't hurt to know how to do this behind the scenes anyway. And similarly, if I have a random DSCP value and I need to know, well, is that AF 39, 32, or is that AF 42, or what is that? So maybe I'll say, let's say somebody told me, actually, let me leave that DSCP 46, and that's EF. Let's suppose somebody said, well, hey, can you, I need to figure out which traffic the AF, or which traffic is, I'm trying to come up with a good one here off the top of my head. Yeah. Match IP DSCP 36. This is what I see in my router. I need to know which assured forwarding setting that is, because elsewhere, like if I'm in call manager in the service parameters, a call manager service parameters and call manager, it lists DSCP values by things like assured forwarding. So which assured forwarding value is 36? Okay, well, we can figure this out. With assured forwarding 36, I would certainly have a 1 in the 32's value, right? So 36 minus 32, well, that's easy, that's 4. I would need a 1 in the 4's place, and then everything else, of course, is going to be a 0, and there's my 36. What AF is that? Well, it's AF4, 2. Being able to convert back and forth is where we're going with this. Everybody good? Questions, issues? Did I lose anybody?
You weren't kidding when you said dirty.
I know. And like I said, and there's charts for this. If you're planning on taking a Cisco practice exam, let's say there's no chart for one. And there are a couple that are used commonly. The ones I would bother remembering are these, are the 46, the expedited forwarding. I would remember the 34, because this is AF41. And that's where your video payload traffic is going to be. Everything else is kind of variations on a theme, but those two values right there, the 34 and the 46, so those are ones I would make sure I keep in my head. It took me a long time to figure out how these bits worked. Because sometimes it's 8, sometimes it's 6, and sometimes it's 5. It's, which bits mean which things. I'm hoping this has been helpful to you. So far, so good. I got one last little piece. This one's going to be shorter than the session this morning. Are we okay with this so far? Greg, Sayed, anybody? Just checking in, thumbs.
I'm going to say yes, but apprehensively.
Okay, well, go ahead, Greg. I'm sorry.
I was just going to say I'm good. Thanks.
You're good? Okay. Well, let me ask you, Perry. So where did I lose you? How about that?
Oh, no, it wasn't that you lost me. It's kind of having to remember the mapping that you have above is kind of the trick that to this whole thing.
All right, I'll tell you what.
That's the key. Yeah.
Let's draw it out again then, shall we? You have a byte. Ignore those. Now redraw your values. Then draw the first line, right? Remember, these 3 bits are IP precedence. Draw your second line, drop probability, and then this last value is always a 0. That help?
Yeah.
Okay.
Actually, yeah, I simplified it.
Yes. And then again, if I have, let's say, AF22. Okay. So you tell me, Perry, AF22, where do I put bits?
Well, in that first column, you're going to have, 0, 1, 0.
Because I have a 1 in the 2's column, hence the 2. Yep.
And then we're going to have a 1 and a 0 in the second column.
Yep.
And it doesn't matter after that.
Right. Okay. And then what's the decimal value of those bits?
Then we're looking at what? 20. Yeah, 20.
You got it. That's it. After that, definitely there's practice involved there, but you have the basic idea. And now if you need to look at a router and you see, match IP DSCP 20, you know what you're looking at. Or if you are mapping things in a router and a switch, you know what values to put. You got it. Yay. Round of applause for Perry. Yay. All right.
Yeah, I'm as dumb as I look. There we go. All right, here we go.
Now, speaking of which, if you have a multi-layer switch MLS, then you can have the switch itself. Remember, this multi-layer switch has layer 2 properties and also layer 3 properties. You can have the switch note the DSCP value in the layer 3 header, and as it's creating the layer 2 header, mark the traffic in those 3 cost bits properly, and vice versa. You could have traffic that comes in with a particular class of service value, those 3 bits in the layer 2 header, and the router, the layers, the multi-layer switch itself, the routing process of the multi-layer switch can then mark the DSCP value correctly based on its programming. Now, the bits in a switch, 0, 8, 16 just goes up by 8s. 40, 48, and 56, right? The 8 bits, the class of service bits in the 802.1q tag, right, go like this. So, but none of those, remember we said that expedited forwarding, right? We said that expedited forwarding is a 46, and we said that assured forwarding 41 was a 34. So I don't see those values here. So how can I get these cost bits as marked by, let's say, a Cisco IP phone or some other layer two speaking device that's going to put bits in those mark those 3 bits? How do I get the multi-layer switch to look at that and put in the correct numbers in the DSCP values in layer 3 header? Well, I can change these values. And a common way to change these values is exactly oops, I put that in the wrong spot, is exactly that. I will go in and the command is, MLS QoS. Oh, I don't remember. I think it's COS to DSCP. Don't quote me on that. It's a global command. I might have that not quite the right syntax. And what I'm going to do here is specify if you see these bits in the COS header, mark the DSCP bits a certain way. And I would say something like 0, 8, 16, 24, 34, 46, 48, 56. And now it will say, oh, if I see, the class of service bits marked a certain way, now I know how to mark the layer 3 header, the DSCP value in the layer 3 header to match what my downstream devices need. And similarly, as the layer 3 process is handing traffic back to the layer 2 process in a multi-layer switch, I would need to do the same thing. I need to tell it, well, if you see a 46, mark the class of service bits this way, et cetera, et cetera. So this is another reason why you would need to know how to convert into decimal so that you can have the multi-layer switch mark the traffic correctly between layer 2 and layer 3, because layer 2 headers get stripped off as you're going into the routing process, right? We need to build them back on correctly. So there you go with that. Couple of last pieces of information with regards to, and forgive me, actually, before I go on, is that groovy? That makes sense? You okay with that, everybody? More fun than humans are allowed to have? Okay. A few more terms that I would like you to be aware of with regards to DSCP values and with regards to QoS in general. One of which is the term PHB, per hop behavior. Per hop behavior harkens back to the idea that each router, independent of anything else in the network, makes its own decisions. Traffic comes into the router looks at its own internal programming, makes a decision about what to do with the traffic, and then egresses the traffic. But each router does it independently. Each hop behaves the way it's told to behave, per hop behavior. This also means that I can mark traffic with DSCP values at one point in my network, and then I can have different routers treated differently if I choose. At the same time, if I want the traffic treated the same throughout my routers, I need to make sure that my routers are, from a QoS perspective, are configured consistently. So per hop behavior is just the idea that once the DSCP markings are set, each router can pay attention, not pay attention, remark them, whatever it does, because it's internal. Another term that you'll want to know is BA, or behavior aggregate. A behavior aggregate is the idea that I might have a bunch of different DSCP values on a bunch of different traffic. If I put a set of DSCP values, 1, 2, 5 of them, and I make them part of the same class. If I do that, what I'm doing is creating a behavior aggregate. And let me make that black instead of green here. For instance, I might say class match all, or match any. This BA, and I'll call it this BA. what was 34? Okay. By creating a single class with multiple DSCP values that belong to the same class, what I'm saying is that the router should handle them the same way. It's different values, it's different types of traffic, but they're all going to be handled with the same behavior. It's a behavior aggregate. It's a set of traffic that will be handled the same way, even if it's different types of traffic. One of the examples I gave earlier this morning was, if I have robots on a manufacturing floor and they're doing the manufacturing, the communications to and from those robots so that they can know what to do is crucial to my business. I might put those kinds of communications in a very high queue, the same queue as like RTP traffic, possibly. So I could mark that traffic with a different DSCP value than RTP so that at some point I could distinguish between them. But I might put them into the same queue. I might put them as the same class of traffic so that I can handle them the same way. I can give them the same level of precedence and priority. So that's what they mean by behavior aggregate. Groovy on per hop behavior and behavior aggregate. Any questions? Comments? Okay. So that is what I had planned to cover today. I wanted to talk about the DSCP values and how they work, and those extra terms that you probably have seen around but don't necessarily know what they are. Thank you for attending. I hope this was helpful and informative, and I'll be sticking around for a little while, so if anybody has questions that they would like to talk about after I'm done talking in about 30 seconds, please do so. It has been a pleasure. Thanks for coming.